Hello students of Seneca and welcome to this episode looking at what you need to know for your 11 plus maths exam. So this is one of 4 episodes we're going to look at for the 11 plus. So if you're going to be sitting in it because you're trying to get into grammar school from September in year 7 or beyond or another time, then there's this video, but there's also 3 other videos for you to look at. So the videos we're going to cover, we're going to look at maths in this video, but we've also got videos on English, got videos on non-verbal reasoning and also verbal reasoning. So check those out to make sure you are as well prepared as possible for that 11 plus exam. So to start with, what you need to know about the 11 plus exam is that there are 4 sections, the same 4 I've just gone through. So that was maths, English, verbal reasoning and non-verbal reasoning. And you need to be able to go through those. And basically the idea of the exam is to check that grammar school is the right is the right place for you, but also that you're right for the grammar school. So it's like an entrance exam to get into the school. But the best thing to do is to approach it with a really relaxed attitude. If it's not right for you, then it's not right for you, and that's not a problem. You'll go to a different school, and I'm sure you'll have a great time. So in this episode, we're going to look through a few topics from the 11 plus maths that you need to know. And we're going to start with angles on a straight line. So you need to know that angles on a straight line always add up to 180 degrees. And you can use this information to solve straight line problems. So for example, if you look here, we've got an angle of 110. We've got an angle that's made by going into a straight line. So to find that missing angle, we just need to do 180, take away 110, which will give us 70 as our final answer. So that's the missing angle. And if you can check your answer at the end by adding those two together, 70 plus 110 equals 180. So to look at a couple of questions with that, remember that angles on a straight line add up to 180 degrees. And that when you're working out a missing angle, we can find the missing angle by adding up the angles we're given and then subtracting them from 180 degrees. So in this example, we've got an angle of 70, we've got also angles on a straight line, and we've got an angle of 70 and an angle of 30. If we add those together, it's 100 degrees. So the missing angle must add up to 180 with those 100 degrees that we've already got. So 180, take away 100 would give us 80 degrees as that missing angle. So let's move on and have a look at something a little different. So in the next part, we're going to look at a similar topic, but angles in a circle. So you need to know that angles in a circle add up to 360 degrees in total. Okay, so if we've got this 240 degree angle here, and we've got a missing angle here, we can work it out using that fact. All right. So remember, they add up to 360. So what we can do is 360 take away this 240 to see what's left over there. And the answer, 360 take away 240, is 120 degrees. So remember, they add up to 360. And if the size of the 2 angles shown in this diagram, we've got one angle here, which is 180 degrees, and we've got another angle here, which is a right angle, which is 90 degrees. Now, if we were looking to find the missing angle in this example, remember that all the angles together add up to 360. So if we've got 160, 160, we can add those together to make, what is it, 220? Should be 220. And then basically we can do a subtraction to work out the missing angle to find out that it's 60. So the missing angle is 60 degrees. So moving on swiftly on to the next topic. Let's have a look at fractions of numbers. It's another tricky topic that people tend to struggle with. So you may be asked to work out a fraction of a whole number as an amount of money or a weight or maybe even a length. Okay. And the method each time is exactly the same. So say we're trying to find 1/5 of 150. What you do is you take you divide by the denominator. Remember, the denominator is the bottom number. So 150 divided by 5, which equals 30. And then you multiply by the numerator, this top number. So 30 times by 1 is 30. So we now know that 1/5 of 150 is 30. So to look at some more examples of this, we've got 4/9 of 720 minutes. Now, just because it's minutes, it doesn't change at all. It's exactly the same process, all right? So first, you make the first sum easier. So you divide by the denominator, so 270 divided by 9. So this is suggesting, because if we're going to do that in our head, we should make it a bit easier by dividing by 10 first to make it into 27. And then we can do 27 divided by 9, which is 3. But we then need to multiply it by 10 again to get the full number. So if we divide it by 10 here, we need to then multiply by 10 to make the answer correct. So then we've got 30 times 4. Now this is saying it's quite a difficult sum. We should divide by 10 to make it 3. And then you do 3 times 4, which is 12. And then you multiply by the 10 again to give you 120. So in total, 4/9 of 270 minutes is 120 minutes. And if you remember that there are 60 minutes in 1 hour, you can convert that into hours. So 120 divided by 60 to see how many hours are in that 120 gives you 2 hours. One more example. So 2/3 of 90. So if we're going to divide by the denominator, we're going to do 90 divided by 3, which is 30. And then we're going to times by the numerator. So then we've got 30 times by 2, which would give you 60 centimeters. Oh, typed it in wrong, 60 centimeters. And that is that. Moving swiftly on before we lose any momentum, we've got prime numbers. So prime numbers are numbers that can only be divided by themselves and by 1. Now the exception is 1. That is not a prime number, but that's actually because it can be divided by itself and 1, but those numbers are the same thing. So 1 is the number itself, and also it can be divided by 1. So that's not actually a prime number, but any other number that can be divided by 1 in itself is a prime number. So between 1 and 5, we've got the numbers 2. That can only be divided by 1 and 2. We've got 3. That can only be divided by 1 and 3. We've got 5. That can only be divided by 1 and 5. So they're all prime numbers. But 4 can be divided by 1, 2, and 4. So that means 4 is not a prime number. So if we're going to list, think about how many prime numbers between 13 and 50 that end in a 7. So if we list all the numbers between 13 and 30 that end in a 7, we've got 17, 27, 37, and 47. And then we work out which of those are prime. So first of all, is 17 prime? 17 can only be divided by 1 and 17, so it's prime. 27 can be divided by 3 as well as 1 and 27 itself. So that is not prime. 37 can be divided by 1 and 37 only. So that means that 37 is prime. And 47 can be divided by 1 and 47 only. Again, so 47 is prime. So in total, we've got 17, 35, and 45 are the ones that are prime. So we've got 3 prime numbers between 13 and 50 that end in a 7. Now that's a difficult question because you've got different parts to it. So you've got, first of all, find the prime numbers. They have to be between 13 and 50, and they end in a 7. So what I'd do is underline the key parts of that question as you go through to make sure you are answering what they actually want. So, which of these numbers are prime numbers? See if you can get them yourself, and then I'll answer them for you. So, 17 is a prime number, only divides by 1 and 17. Same with 23, prime number only divides by 1 and 23. And here is a list of, well, this is counting the even numbers, but here we go. There's some other things going on here. So what this is showing basically is all the times tables. So 5, 10, and then it's going to, anything that's left over are what becomes prime numbers. Okay, so all the purples there were prime numbers if you want to pause and have a look at that. So moving on from prime numbers to ratios. We're not going to stop there, we're going to keep on going. So a ratio shows how much there is of one thing compared with another thing. So we write ratios like this. This ratio is 2 blue blocks for every 3 red blocks. So we've got 2 blue blocks, 3 red blocks, and we write 2:3. Now to find the number of equal parts, we add the 2 sides of the ratio. So there we go, 2 plus 3 to find out. You can see it in the picture, but that tells you basically there are 5 parts in total. 2 of them are blue, 3 of them are red, 5 in total. So to look at like a question that you might see for that, the ratio of cows to sheep in a farm is 2:3, and they have 500 animals in total. So how many cows are there and how many sheep are there? So the number of equal parts is 5. That's because we add the 2 and the 3. And there are 500 in total. So the total number of animals, 500. We divide it by how many sort of parts or boxes we're trying to split it into. Tell you that there's 100 in each of those boxes. And then from there, we can work out that two of those 100 boxes are going to be for cows, so that's 200 cows, and 3 of the boxes with 100 in them are for sheep, so 300 for sheep. So the overall answer is 200 cows and 300 sheep. And we can check that answer at the end. You can always check stuff with maths, which is nice, is that you can just basically add those 2 together and check you got to the original answer. Well, if you remember, we had 500 animals at the beginning, so 200 plus 300 would give you 500, so that works. Moving swiftly on, alternating pattern sequences. This is the sort of trickier area of sequences that you need to know about. So you need to know that often sequences they'll contain 2 separate patterns. So you can look and you can sometimes just see one pattern, like add 5 each time or add 1 each time would have something. But if you've got something with alternating patterns, you need to be able to spot them too. So this is an example of something like that. So here we've got 2, 3, 5, 9, 17 as the start of the sequence. So if you look between the first and the third and the 5th numbers, you've added 2 each time. And then between the second, 4th, and 6th, we're taking away 2 each time. So there's 2 different sequences sort of interwoven with each other, right? So again, we're adding 2 each time here, and then the other sort of alternating sequence is that we're taking away 2 each time. So look out for those. So what are the 2 missing numbers in this sequence? So you've got to go through this step by step, okay? So let's start with a pattern, with pattern 2, as the pattern is easiest to work out. So pattern 2, we're going from A to 18 to 21. So that implies to me that we're adding 3 each time. So to go backwards to find out what A is, we should take away. So this shows we're adding 3. So we're adding 3 each time. So then to calculate what A is, we do go backwards through the sequence, do 18, take away 3, which is 15. And then we can work out B. So B is between 90 and 94 in pattern 1. And so we got 90, then B, then 94. Okay, so if we're assuming that the pattern stays regular, we know that there's 2. The difference between 90 and B will be 2. It's half the difference between 90 and 94. So if we work out 90 divided by 90 take away 90, 94 take away 90 gives us 4. So the difference between 90 and B is 2, and then the difference between B and 94 is also 2. So we can do 90 plus 2 to give us 92 as the answer to B. So which is the next number in this alternating pattern sequence? So if we alternate pattern, we know we're looking at looking at every other number in the sequence. So 8 goes to 7, goes to 6. So those numbers are subtracting by 1 each time. And here we're going from -1 to 4 to something. Now, if we're going -1 to 4, we are adding 5 each time. So if we're adding 5, and then we're adding 5 again, so 4 plus 5 give you 9. So that is alternating sequence. The very last thing we're going to look at is perimeter and area. So let's look at specifically the area of a triangle and how to find that. So the angle, or so the triangle, is half a quadrilateral. So you find the area, you need to multiply the base and the height, and then divide your answer by 2. So look at an example. We've got a base of 6 here and a height of 4. If we want to find out the area, we do base times height, 6 times 4, or 4 times 6, same thing, to give you 24. And then we halve it to tell you that the area of that triangle is 12. Now, the units in this is centimeters, so we use centimeters squared as the area. So let's look at another example. We break up 22, so multiplying 5 by 22 is quite difficult. So if we partition 22 to, say, it's equal to 20 plus 2, we can do 20 by 5, and then 2 by 5, do those two multiplications, and then add them together to make it easier. So 20 times 5 is 100. 2 times 5 is 10. So if we add them together, the answer to 22 times 5, the base times the height, is 110. Now remember, we're not done yet, because it's a triangle, not a quadrilateral. We need to divide by 2. So 110 divided by 2 gives you 55. And the answer is 55 centimeters squared. Now it's really important to also always include the right units. If you're working with area, you'll be working in squared units. So like centimeters squared, meters squared, kilometers squared. So which of these triangles has the smallest area? So we have 4 by 12, base of 4, height of 12, base of 4, height of 10, base of 3, height of 11, base of 5, height of 8. To work out the area for each one of those, we will work out that this one will have the smallest area. Remember, you can just do base 3 times height 11. 3 times 11 is 33. If you halve that, it's going to be 16.5 centimeters squared. If you compare that to the other areas, you'll find that that is lower. So that is all we're going to look at in this video. It's been really good to go through some maths stuff with you. I'm going to do some more videos looking at the other 3 areas you need to know for your 11 plus exam. So looking at your English, your non-verbal reasoning, and your verbal reasoning. Those things will all be included in other videos, so keep an eye out for them. And if you want to try and have a look at Seneca's free courses, they are completely free to use on senecalearning.com. So go ahead and sign up there and do some more practice for your 11 plus exams. Good luck.